So let's take a look at how to solve exponential equations. First, we'll look at examples where the bases are the same, and then we'll take a look at how to solve them when the bases are different. So here, notice that you have an equation where the bases are the same. So 5 to the 2x is equal to 5 to the 3x plus 2. So if we use the one-to-one property here, we can set the exponents equal to each other, and then just use inverse operations to solve for x. So here, I'm going to go ahead and subtract 2x from both sides. And at the same time, I'll go ahead and add 2, or excuse me, subtract 2 from both sides as well. So here we're left with negative 2 on the left and x on the right. So x is equal to negative 2. All right, let's consider this next example. So what happens when we have an equation like this where the bases don't quite look the same? Well, we can rewrite this. So here you have a base 5 and a base 25, but we can rewrite 25 so that it has a common base 5. So on the left here, I've got 5 to the 2x, and I can rewrite 25 as 5 to the second power, and that is raised to 3x plus 2. So then now I've got the same bases. I can just focus on the exponent. So using that one-to-one property, I can set those exponents equal to each other. So 2x is equal to 2 times 3x plus 2. Let's distribute this 2 to the 3x term and the 2 there. And so on the right-hand side, I've got 6x plus 4. And then again, let's go ahead and subtract 6x from both sides. And so that leaves me with negative 4x is equal to 4. Divide both sides by negative 4. X is equal to 4 divided by negative 4, or negative 1. Okay, so x is equal to negative 1. All right, let's consider another example. So here we have 5 to the x is equal to the square root of 5, and we want to solve for x. So again, think about how you can rewrite this square root of 5 so that it's in base 5. Well, we can rewrite square root of 5 as 5 to the 1/2 power. And so again, using that one-to-one property, we can set the exponent equal to each other. So x is equal to 1/2. Now in the next slide here, I'm going to show you what this solution looks like graphically. Okay. So graphically, I can type in this equation to the left here. I can call this equation g of x, and I can call this equation on the right, I can call this equation f of x, and the solution is 1/2. So when I take these two equations and I set them equal to each other, right, where is that point of intersection? So I'll show you that in the next slide. Okay, so here, I hope that you can see that I've got 5x here, which is that red curve, and the square root of 5, which is the blue curve. And graphically, we can see that those two equations are equal to each other at x equals 0.5, or 1/2. So we can also see solutions to these type of equations graphically as well as algebraically, which is what we did previously when we solved for x algebraically. Okay, I want us to take a look at one more example here.